Hi, my name is Alex. I'm an engineer at Keysight Technologies. Spectrum analysis is important for understanding the frequency domain characteristics of components, devices, and systems. I'm going to show you how to avoid 8 mistakes that plague the accuracy and effectiveness of spectrum analyzer measurements, including using the wrong detector, using the wrong averaging type, measuring the analyzer's own internally generated distortion products, incorrect mixer level for EVM measurements, not using a single sweep when remotely controlling the analyzer, not synchronizing the measurements with a star OPC query, not turning off the display and not using binary data types when transferring data for speed, and feeding too much power to the input of the spectrum analyzer. The first mistake people make is choosing the wrong detector type for the signal in question. For measuring noise-like signals, a sample detector is effective. Each trace point represents a single, evenly spaced sample across the span of the frequency domain. However, the sample detector can completely miss a single tone if the resolution bandwidth is not set wider than the trace interval. Observe how the CW signal disappears as I decrease the resolution bandwidth of the MXA when using a sample detector. In most spectrum analyzers, the normal detector is the default detector. A normal detector always shows the correct amplitude for a CW signal regardless of the resolution bandwidth. It displays the peak value of a signal that rises or falls during an odd trace point and shows the minimum value during an even trace point. This is useful when measuring noise-like signals because the peak-to-peak value is accurately represented. The second mistake when using spectrum analyzers is choosing the wrong averaging type. Most analyzers offer log video averaging or RMS power averaging. Log video averaging performs the averaging on a logarithmic scale. This is useful for measuring CW signals near the noise floor and improves the signal-to-noise ratio. When measuring noise-like signals, such as WCDMA, RMS power should be used if averaging is applied. Log video averaging will cause the signal to be measured as much as 2.5 dB below the actual signal level. The blue trace is a WCDMA signal measured using RMS power averaging. The yellow trace is the same signal measured with log video averaging. Observe the 2.5 dB drop. The third mistake is measuring the analyzer's own internally generated distortion products. This could be due to third-order intercept, adjacent channel power, or harmonic signals. The amplitude of the distortion products is normally related to the level of the input signal of the device under test. Make sure not to confuse these internally generated signals with your measurement. The analyzer's mixer leads to the fourth common mistake when making error vector magnitude measurements. A mixer level that is too high or low can degrade the performance of a measurement. Using Keysight's 89600 VSA software connected to an MXA, I am measuring a QPSK signal. To optimize the measurement, decrease the input attenuation until an ADC overload is met. Then, increase the input attenuation until the overload condition is resolved. Observe the change in EVM while the attenuation is changed. The fifth common mistake is not using single sweep mode. It seems intuitive that continuously sweeping would run faster, but under remote control, the analyzer will actually run slower. Once an initiate command is sent, the instrument must abort the current sweep and reinitiate the measurement. To put the analyzer into single sweep mode, use the initiate continuous off command, then to trigger a measurement, use the initiate immediate command. The sixth common mistake is not synchronizing with the operation complete flag. Not using the flag or using sleep commands can lead to synchronization errors. Checking the flag before starting a measurement will ensure synchronization is maintained. The seventh mistake occurs when transferring data. Not turning off the display or using binary data types can slow down your automated measurements. To maximize test throughput, disable the instrument display using display enable off. Use binary data to reduce the amount of transferred information. To set the data type, use real32 for 32-bit binary data, or for 64-bit, use real64. For more help with automating your measurements, check out the Keysight support forum on remote control and programming. The last of the 8 errors, feeding too much power into the input port, can be the most expensive of them all. Most spectrum analyzers' input limit is 1 watt or plus 30 dBm. If signals with excess powers are fed into the input port, the front-end electronics can be overloaded or damaged. When working with signals of higher power, input limiters should be used. Keysight's power limiter webpage can help you find a limiter to meet your testing needs. I've shown you how to avoid some common mistakes when using spectrum analyzers. For more information, check out the Application Note 150 Resource Toolkit. Thanks for watching.